So let's start with our first chapter, that is understanding infrastructure as a code. So we will start by gaining a bit knowledge about infrastructure as a code, and then we will further move towards Terraform, right? So these are the objectives of this lesson. After completing this lesson, you will understand the core concepts of infrastructure as a code, the need of infrastructure as a code in the world, and also you will know about the best practices of infrastructure as a code. So, well, let me take you to the time when there was no cloud. During this pre cloud era, organizations relied on traditional on premises infrastructure to meet their computing requirements. At that time, when organizations comes up with an idea, they need to write the whole software for their application and then they deploy that onto their on premises infrastructure, right? So organizations used to have their own computer systems and physical components stored on their own buildings called data centers, which contains all the equipments. They had to buy and maintain their own servers, storage, switches, networks, routers, so on and so forth. So they were responsible for storing and protecting their own data on their physical storage devices. And this was a very challenging process. So it means that it was much harder to get started if organization wanted to host something. And there were not companies out there like Oracle Cloud or AWS Cloud to do so at the click of a button. Instead, they often need to buy capital expenses like big servers and deals with all that stuff, right? So in this figure, let's look at the purpose of each component in the data center. So here is the databases, that is for storing and managing your data, and physical servers that host applications and processes data. There are switches, like they help in managing data transfer and data traffic within the data center. And also there are firewalls that enforce security policies to protect data and applications. And also you can see here there are routers which direct data flow within and outside the data center. And also you can see here there's an internal cloud out there that provides virtualized computing resources for applications. And last but not the least, here you can see there is an internet, VPN, and dedicated lease lines that connect users and external networks to the data center. So this whole data center resides on a company premises itself, right? So that was the era, that was the pre cloud era, right? So fast forward to 2010s, and the whole game of getting our application out there look a major turn, that took a major turn. Now you will start with your idea, but here where things get interesting. Now instead of relying on physical servers and dealing with all that infrastructure jazz, you can deploy them on the cloud. So deploying to the cloud has become the new norm. While you can still buy servers and set up your own hosting, most companies, especially startups, prefer the flexibility of the cloud. So it's like having on demand resources at your fingertips, and you can only pay for what you use. So no need to worry about managing a whole data center. Leave that to the particular cloud provider, right? That is what we call cloud evolution, right? So what has changed now? Infrastructure is now provisioned via APIs called application programming interfaces. An API is a piece of software that allows two applications to talk to each other with the help of requests and responses. Think of it like a conversation with the cloud provider, like you say, hey, I need 5 more servers. Within a few minutes, they are up and running, right? So now the speed at which you can bring up or down your resources or servers is totally game changer. Back in that day, if you bought a server, you would want it running for years to get your money's worth. But now, if you anticipate a surge in demand, you can scale up your infrastructure in minutes. And in the same way, let's say on your website, the big sale is over and the traffic drops. No worries, you can scrape those extra servers just as quickly as you want. So, also for the infrastructure, we earlier think it as the long lived and mutable. Mutable, I mean, it can change. So, in order to manage the infrastructure, administrator takes care of all the servers and make sure that it remains up to date and running all the time. So, they have to make changes over time. If some of the services get offloaded, so rather than rely on long lived and mutable infrastructure, it is now becoming short lived and immutable, which means we can still have the brand new server with already installed dependencies and tear down the old ones. So each individual unit is short lived and immutable, right? So here you can see in this picture, users and applications ask the cloud providers, that is CSP, cloud service provider, for resources like computing power or storage or databases. It can be any. So there are four steps while resource provisioning, that is modeling, discovery, monitoring, and selection. What it means, modeling means planning. So what it has, guessing what resources will be needed in the future. That is what comes under the planning, and you can say modeling. And next is discovery. Discovery means finding or looking for available resources that matches what is requested actually. And then monitoring, keeping an eye on how resources are being used and if they are working well, how they are being used. That is what comes under monitoring. And next is selection. So picking up the best resources based on how well they work, their cost, and what is needed comes under the selection component. So once resources are picked, they are given to the cloud services and applications in a CSP's system, that is cloud server provider system. And then those provisioned or created resources are sent to the users and applications for their use. Right? This is the circle of provisioning and then giving back to the users and applications for use. So next we'll discuss the approaches to provision cloud resources. So there are three main approaches to provision cloud resources. For most of the people who is who is getting started with the cloud for the first time, can provision the resources by logging and navigating to the cloud console, right? So this is a picture of GUI that is belong to the Oracle Cloud Console in this slide, right? So cloud providers offer graphical user interfaces that allow user to interact with and provision cloud resources visually. While GUIs are more user friendly and provide a visual representation of your resources, they may not be as efficient for large scale or automated deployments compared to IAC, or you can say CLI methods. That is what we are going to discuss now after this GUI, right? So yes, it is feasible for the limited number of provisioning, but what if your DevOps teams want 50 resources at once for its team? And when you provision resources with GUI on cloud, it takes time, around 3 to 4 minutes in provisioning single resource. So in that case, provisioning through the code is the best option, right? So the next approach is using command line interface. So all the major cloud providers give you the access via command line interface. Like Oracle provides the CLI, you can use that by downloading certain packages, right? So there are two different ways to access command line interfaces in OCI, because we are going to use OCI, that is Oracle Cloud Infrastructure, for our demos. So that is why I'm talking about OCI specifically, right? So you can access OCI by using your own local system command prompt or using OCI's cloud shell. That same happens with every cloud provider. It can be AWS. AWS also provides you the cloud console, and also it provides you the CLI of AWS. Okay, so if you are using local system command prompt to access the cloud provider CLI, it can be AWS, it can be OCI. You can use your own machine resources and manage CLI tools locally by installing and configuring them in that case, right? So this method requires downloading tools like Terraform onto your system. And if you are approaching to the approaching via cloud shell, that is AWS cloud shell, or by OCI cloud shell, then you need not to install or configure CLI tools on your local machines, because cloud shell comes with pre-configured Terraform tools like Terraform, and also with Git. So this method is convenient for users who prefer a browser-based environment and don't want to set up the tools locally. So both methods here are for interacting with OCI services or with AWS services and managing cloud resources, but these are different in the terms of convenience and also in the terms of resource management, right? So this is a CLI environment, there are two ways to access this CLI environment of cloud. You can use your local system, or you can also use the cloud provider's shell, right? So now the third approach is infrastructure as a code. This is the one we will really focus upon. So infrastructure as a code is a method where you manage and provision your cloud resources using code, just like writing a recipe. So instead of clicking buttons in a web interface, you write scripts that describe what resources you need, like servers, like databases and networks, and how they should be configured. So when you run these scripts, they automatically create and set up your resources in the cloud exactly as you specified, making the process faster, more consistent, and easier to repeat. There are several benefits of this method. Firstly, you always know exactly what is provisioned at any given time. So, and yes, it is easy for someone to go into GUI and provision something by navigating through the couple of pages, but it is harder to find about what exactly the state of the current infrastructure is. Let's say if you are provisioning multiple environments like staging environment or production environment. So what the staging environment is, let's look into this first. A staging environment is used for testing purposes, like testing resources before deploying them to production. And if you talk about production environment, so the production environment is the live environment where the actual end users access the application or service. So if you're provisioning multiple environments, that is staging environment and production environment, it is hard to find what exactly the state of current infrastructure is, because you are dealing with the two environments at one time, right? So in that case, you don't have any guarantee that those are same. So by defining things as code as in configuration within your code base, you have much higher confidence about what actually have deployed, right? So also you can take the copies of the same things and be confident they are deployed identically every time you use that particular saved code, right? So the next we will discuss what is infrastructure as a code. So let's discuss the problem statement first. You know, manually keeping the track of project dependencies and configurations can become overwhelming and prone to errors. Sometimes an application may work fine in a developer's environment but fail when deployed elsewhere due to various reasons like incorrect configurations or missing dependencies. So, to prevent such issues, it is crucial to minimize manual setup tasks. This is where infrastructure as a code saves the day. So, infrastructure as a code is an approach in which infrastructure, including servers, networks, and other components, is managed and provisioned using code or scripts instead of the manual processes. So it lets developer to focus on the code only and rest of the things are taken care of by this methodology. A popular tool for implementing IAC, that is infrastructure as a code, is Terraform. So in simple words, infrastructure as a code allow you to describe your desired infrastructure in a file or in a script, and then the tools like Terraform will create or modify the infrastructure to match that defined state. So what the Terraform is? Terraform is a tool provided by infrastructure as a code to define and manage the infrastructure over the cloud depending upon the user requirements. Right? So the next is we will discuss the basic ways to manage infrastructure through IAC, that is infrastructure as a code. So typically IAC tools are divided into the ones that do configuration management and the ones that do provisioning management, right? They are both steps of the deployment processes, but there are certain differences between them. So, provisioning involves setting up IT infrastructure, including virtual machines, databases, access to the resources, and making them valuable and available to the users. So, this process prepares the foundation of IT environment, just like setting up the entire stage before play. So, here one can use the tool like Terraform. And what the configuration management is? So configuration management is all about maintaining and managing that infrastructure over time to ensure it continues to meet the needs of the production. So configuration management occurs after the provisioning and involves tasks such as installing software, configuring sources or configuring servers to the desired state and maintaining them over time. So this ensures that infrastructure remains consistent and operational according to the specified requirements. So IAC tools like Ansible can be used for configuration management, right? So this is how infrastructure as a code works. The team writes the infrastructure configuration in a required programming language, and the code files are sent to the code repository called version control system such as Git, as it keeps the track of the changes made to the infrastructure configurations and code and revert to the previous versions if needed, because it saves the each changes made to the code separately. That is what the work of the version control system. So an ISE tools runs the code and performs the required activities. Here you can see there are a lot of infrastructure as a code tools available, like here Ansible, Chef, and Puppet are there, and basically this Ansible, Chef, and Puppet are for configuration management, which comes after provisioning. And AWS Cloud Formation is especially for provisioning resources on AWS Cloud, and Terraform is the tool which particularly for a provisioning tool that supports multiple cloud providers. Every time we push the same code, it will give you the same consistent provisioned resource. For example, if I need 25 copies of developmental environment for different people in my team, I can take one infrastructure as a code source and deploy it 25 times and have that same environment for all my teammates. So it increases efficiency and reduces risk, right? Next is, what problem does IAC solves? First is cost, then scalability and availability, and then inconsistency. We will discuss it one by one. So the first is cost efficiency. We get cost efficiency by using this IAC. With manual infrastructure management, organizations often have to hire numerous professionals to handle different tasks, from network engineer to hardware maintenance technicians, and this can lead to higher labor cost, right? So infrastructure as a code automates many of these tasks, reducing the need for manual interventions and thereby lowering labor costs, right? Next is scalability and availability. So manual configuration processes are often slow and cumbersome, leading to difficulties in scaling infrastructure up or down rapidly in response to the changing needs. So this can result in application performance issues during spikes in access, as administrators struggle to provision server quickly enough. So IAC enables rapid and automated provision of resources, allowing organizations to scale their infrastructure more efficiently and maintain high availability for their applications. Next is inconsistencies. So when multiple individuals are involved in manual configuration and deployment processes, discrepancies and inconsistencies are almost inevitable. This can lead to configuration errors, or it can also lead to security vulnerabilities and operational inefficiencies. So IAC eliminates manual intervention by defining infrastructure configuration in code, ensuring consistency across environments and reducing the likelihood of errors. Right? So next is different approaches to infrastructure as a code. So there are two different approaches, that is declarative and imperative. In a declarative approach, you only need to define the desired final condition of infrastructure without going into the detail on how it should be achieved. So it is a dominant method because it requires less knowledge on the user's part and it always produces the same result. This is done via declarative language such as SQL, or it can be YAML, or it can be JSON, right? And if we talk about a imperative approach, it is also called a procedural approach. So in that approach, you must define specific step-by-step commands to achieve the required configuration. Here you can be very detailed and creative, and you can create complex configurations, having more control over the task, but you do need a high level of skill to write those commands with the language like Java, Ruby, or Python. So there is no right and wrong method here, but in general, if you are building a large infrastructure, you might prefer the automation, right? So but if you are planning to start with a few scripts, the imperative approach will work fine. So next, we will discuss benefits here. So the first benefit is speed. So IAC enables rapid provisioning and configuration of infrastructure through automation. So with IAC, resources can be deployed and configured in minutes or even seconds as compared to the manual processes which are slow and error prone. So this method helps organization to respond quickly to changing business needs and reduces time to market for new application and features. Right? Next is consistency. So by defining infrastructure configuration in a code, ISE ensure consistency across different environments, whether it is a developmental, testing, staging or production environment. The same code can be used to provision infrastructure, reducing configuration drift and ensuring that environments are identical. So this consistency minimizes errors and enhance the reliability, and also it simplifies troubleshooting. Next is accountability. So with infrastructure as a code, changes to the infrastructure are tracked and managed through version control systems like Git that we have done earlier. That version control system role in infrastructure as a code working, that is what we'd have done here, right? Right, here we have done the role of version control system in infrastructure as a code. So so this provides visibility into who made changes, what changes are made and when they are made, right? That promotes accountability and facilitates auditing and compliance efforts. Next is low cost. Automation through ISE reduces the need for manual intervention, which in turn lowers the labor cost associated with infrastructure management. So additionally, ISE helps optimize resource utilization by enabling dynamic scaling and efficient resource allocation, reducing unnecessary spending on idle resources. Right? Next is efficient. So ISE streamlines and standardizes infrastructure management processes, making them more efficient and less error prone. So by automating repetitive tasks and leveraging reusable code, ISE frees up valuable time and resources that can be redirected towards innovation and strategic initiatives. So overall, IEC improves the agility, reliability, and cost effectiveness of IT operations. That enables organizations to deliver value to their customers more efficiently and effectively. Right? So, now we will discuss IAC tasks. So a wide range of infrastructure as a code tools available today help IT managers address the infrastructure management tasks, that is provisioning and deployment, configuration and orchestration. So first task is provisioning. So IAC tool can automate the provisioning of infrastructure resources as they allow to define the desired state of your infrastructure in a code and then automatically creates and configure the resources. Right? So this streamlines the process of setting up the servers, networks, database and other components. So the next task is deployment. So IAC tools are instrumental in automating application deployment. You can use IAC to define the infrastructure required for your application, ensuring that the right resources are available and properly configured. So this supports rapid and consistent deployments, whether for a new application or updates, or you want to update the existing ones. So the next task of IAC is configuration. So infrastructure as a code tool help and maintain the configuration of infrastructure resources, as it helps in specifying how each resource should be configured, including their settings, software installation and security policies. So any changes to the configuration can be made through code, ensuring that infrastructure remains in the desired state. Right? Next task is orchestration. So infrastructure as a code tool provides the capability to orchestrate complex workflows involving the multiple resources and services. You can define the relationships and dependencies between infrastructure components and use IAC to automate the execution of these workflows. So, this ensures that tasks are performed in coordinated and consistent manner. So, these are the four important tasks of infrastructure as a code tool that is performed by infrastructure as a code very efficiently and in a very consistent manner. So now we will discuss how infrastructure as a code helps in DevOps operation. First is how it helps in version control systems. So IAC files such as those written in tools like Terraform, Ansible or Puppet are stored in a version control systems like Git, right? So this allows for versioning, collaboration and change tracking similar to how application code is managed, right? Next is automated provisioning. With IAC you can automate the provision of infrastructure, as this means you can define the desired state of your infrastructure in a code, and tools will automatically configure and provision resources to manage that state. And if we talk about the consistency and reproducibility, so IAC ensures this. Whether it is a developmental environment or testing or staging or production, the same code can be used to provision infrastructure. That reduces the configuration drift and ensuring reproducibility. Right? Next is scalability and flexibility. So IAC allows for easy scalability and flexibility. As code, infrastructure configurations can be modified, duplicated, and scaled up or down rapidly and consistently in response to changing demands or requirements. So, next is immutable infrastructure. IAC encourages the concept of immutable infrastructure, where infrastructure components are replaced rather than updated. Right? We have discussed this immutable concept earlier in this session, right? So this helps in maintaining a reliable and consistent environment, as changes are made by creating new infrastructure rather than modifying existing components. Next is testing and validation. IAC enables automated testing of infrastructure configurations, just like testing application code. IAC can be tested using automated tests to ensure that the infrastructure behaves as expected. Next is collaboration. Since IAC is a code, it facilitates collaboration between different teams such as developers, operations, and quality engineers. So everyone can contribute to the infrastructure code base, making it easier to align infrastructure changes with the application changes. So we can say IAC is a foundational practice in DevOps that allows for automation, consistency, scalability, and collaboration required to deliver high quality software at speed, right? Now now we will discuss IAC provisioning tools. So there are some cloud specific and cloud agnostic provisioning tools. So cloud specific tools builds application native to the cloud environment. So cloud formation is specifically for AWS, and Azure Resource Manager is specifically for Microsoft, and Google Cloud Manager is specifically for Google. So where, as you can say, Terraform is a cloud agnostic tool that aims to design applications that can run seamlessly across any cloud provider. It can run on Oracle, it can run on AWS, GCP, and many more. Because it supports numerous and multiple cloud providers, by using this tool, you can configure infrastructure on multiple cloud providers by writing and running single script. So by using this tool, you can configure infrastructure on multiple providers, right? So next we will discuss IAC best practices. So make your code single source of truth. So you should explicitly code all the infrastructure specification in a configuration files. Your configuration files should be the single source of truth for all your infrastructure management concerns, right? Next is version control all of your configuration files. This probably should go without saying, but put all of your configuration files under version control systems or under source control systems, right? Use little documentation or none at all for your infrastructure specification. So this point is the local consequence of the first one. Since your configuration files should be your single source of truth, there should be no need for more documentation, right? So external documentation can easily get out of sync with the real configurations, but that won't happen with the configuration files if you maintain it in a right manner. Test and monitor your configurations. So IAC is a code, and like all code, it can be tested, right? It should be tested. So by employing testing and monitoring tools for IAC, you can check for errors and inconsistencies in your servers before you deploy them to the production environment, right? So this is the summary of this chapter. In this chapter, you have learned about infrastructure as a code, the need of infrastructure as a code in technological world, and also we have studied about the best practices of infrastructure as a code along with its working process, and also we have studied about the cloud evolution and how the resource was provisioned in back in the array of pre-cloud era. So there are no practicals for this lesson. Now we will discuss a quiz. So the first question is, what is infrastructure as a code? It's a programming language, or it's a methodology for managing and provisioning infrastructure through machine readable script files, or it is a hardware device, or it is a cloud computing service. So the correct option is option B, right? Next is, which of the following is benefit of using infrastructure as a code? Manual intervention, increased consistency, lack of version control, and limited scalability. So if we're talking about benefit, We will go with option B, that is increased consistency. Next question is, what is the purpose of version control in infrastructure as a code? To track the changes to the infrastructure as a code over time, to control access to infrastructure resources, to limit the number of updates to infrastructure, or to replace the need for documentation. So the correct option is option A, that is to track changes to infrastructure code over time. So here is the end of this chapter. Now we will start with another chapter, right?